probably lived through at least one mysterious outage where nothing obvious changed, no one pushed a bad release, and yet a critical system went dark. Then, a few painful hours later, someone discovered that a certificate had quietly expired, or a long-lived token stopped working, or a bot account behaved exactly as configured while everything around it had drifted. This narration of Machine Identity Riot, Certificates, Tokens, and Bots Gone Wild is part of the Wednesday headline feature from Bare Metal Cyber magazine, developed by Bare Metal Cyber, and it is aimed at you as a thoughtful security or technology leader who is already feeling that something about identity has escaped the human frame. The core idea is simple but uncomfortable. In most modern environments, machine identities now form the real trust fabric of the business, yet they are still managed like background plumbing. Certificates, tokens, keys, and automated accounts are everywhere, connecting workloads, pipelines, and platforms at a speed and scale that no team can track by memory. They keep services talking to each other, move money and data, and drive automation in ways that do not show up clearly on your usual dashboards. When that fabric is opaque, fragmented, or owned by nobody, you do not just get annoying outages. You get a slow, steady erosion of control over who or what can do what inside your environment. If you count only human users, your identity systems probably look large and complex already. You have employees, contractors, privileged accounts, and partners, each with controls, approvals, and multi-factor enforcement. But as soon as you add the non-human side, the proportions flip. Every internal service that terminates encrypted traffic has a certificate. Every integration between products or platforms uses a token or shared secret. Every piece of automation, from infrastructure scripts to deployment jobs to chatbots, runs under some kind of account. In a typical enterprise, those machine identities outnumber people by a wide margin and touch more critical paths than any single employee ever will. The reasons are structural. Cloud adoption, platform engineering, everything as a service, and the push toward automation all create new non-human identities by default. A cloud-native application with microservices can have dozens or hundreds of workloads that all need to prove who they are to talk to each other. A regulated bank might add only a small number of staff each year, but add hundreds of new service accounts, internal certificates, and signing keys as it modernizes channels and products. Even a conservative industrial company ends up with layers of gateways, controllers, and management tools, each with its own device certificates and integration tokens. The machine population grows every quarter, while most governance, risk, and compliance conversations still assume that people are the center of the story. From a machine point of view, the logic of trust is straightforward. A caller presents a credential. Some authority verifies that credential. A decision engine grants or denies specific actions. The complexity comes from how many types of credentials and authorities you have allowed into the environment over the years. There are internal and external certificates. There are access tokens from identity providers. There are shared secrets and keys for legacy systems. And there are accounts that look like users but are really automation in disguise. Public Key Infrastructure, PKI, issues and validates certificates. Application Programming Interface, API, gateways trust tokens and keys to decide which calls to accept. Transport Layer Security, TLS, termination points rely on a chain from a certificate authority, CA, to decide whether a peer is real. Each of these components plays a role, but they rarely grew up as one coherent design. Underneath the protocol names, you can squint and see the same pattern repeating. Something vouches for the identity of a workload, integration or bot, and something else interprets that assertion to grant access. APKI hierarchy lets one service trust another because both ultimately chain to the same root. An identity provider issues a token with claims that an API gateway interprets as scopes. A cloud platform presents the metadata of a running workload instead of a static key. For a leader, the important questions are not about cipher suites or claim formats. The important questions are which authorities you rely on, who runs them, which logs prove what they decided, and how fast you can revoke their decisions when something goes wrong. The fragility shows up when you look at ownership instead of architecture diagrams. One team worries about PKI and certificate issuance, but does not control how private keys are generated or stored by applications. A different team runs the single sign-on service and handles human login flows, but does not see the service-to-service paths that use the same protocol family. Platform engineers focus on container and workload identities inside clusters, while line-of-business teams manage their own software-as-a-service connectors and API keys in vendor consoles. Over time, you end up with islands of well-run trust in a sea of "we think it is fine," where bots, scripts, and bespoke integrations live under assumptions that no one can easily explain. That is fertile ground for the kind of riot this article is named for. You have probably experienced machine identity failures already, even if the incident report did not use those words. Maybe a TLS certificate on a load balancer expired and took out a customer-facing service, forcing a scramble to generate and deploy a replacement under pressure. Maybe an internal alerting integration stopped sending events because an API key was rotated in one system and not updated in another. Maybe an automated deployment job kept working long after anyone remembered who created it, because it held a long-lived token that no one dared to revoke for fear of breaking something. Each of these gets filed as root cause, human error, or gap in change management. But the deeper cause is that no one really owns the birth, life, and death of those credentials as a system. More worrying, many failures do not explode loudly. Long-lived tokens with broad permissions are reused, copied into scripts, and shared between tools just to keep things moving. Service accounts created for a one-time project quietly stay in place, still bound to production databases or administration consoles years later. Bots are granted access to entire application domains because designing fine-grained scopes seems hard and urgent deadlines are in the way. You have invested in secret management tools and vaults, but teams still cache credentials in configuration files or environment variables that never come under central scrutiny. On paper, there is a strong control environment. In reality, there is a shadow ecosystem of machine identities that almost nobody can see clearly. Attackers love this pattern because it gives them durable, quiet access. A phished human login may trip alarms, lockouts, and behavioral analytics. A stolen API key from a forgotten integration or a token scraped from a log file on a build agent can let them operate for a long time with little noise. They can impersonate trusted services, pull sensitive data, or push fraudulent operations without ever touching a user interface. Even without an adversary, the same weaknesses undermine reliability. One overlooked certificate can take out an internal control plane that other systems depend on. A misconfigured bot can delete records, kick off the wrong workflow, or flood downstream services with malformed traffic. These events are separated in time and spread across teams, so they rarely change strategy. They are treated as isolated mistakes, not as signs that the trust fabric itself is out of control. The way out starts with accepting that machine identity is a lifecycle problem. Each certificate, token, key, or bot account has a beginning, a period of legitimate use, and an end. Today, most organizations only see the middle. Identities appear because someone clicked in a portal, ran a script, or followed an onboarding guide. They linger until they cause enough pain that someone cleans them up. Leaders who want a different outcome have to define the stages intentionally and insist that systems and teams design around them. That means asking consistent questions about how identities are discovered, how they are issued, how they are rotated, and how they are revoked or decommissioned in a way that does not depend on individual heroics. In practice, this shift usually means consolidating and creating opinionated defaults. Instead of letting every team run its own CA, create its own secrets in unmanaged vaults, or generate API keys in vendor dashboards, you sponsor a small number of shared authorities and secret stores that are treated as core platform services. Developers obtain credentials through code or automated workflows that embed policy rather than by emailing a security team. Short-lived, purpose-bound credentials become the standard, reducing the upside of theft and the blast radius of mistakes. Logs from issuance, verification, and revocation flow into a central place so that risk and incident response teams can reason about what really happened. You still need local expertise, but the system is no longer a patchwork that only a few individuals understand. Once you frame machine identity as a lifecycle, the next question is who owns it? Many organizations have tried to fix these problems through a series of projects: a PKI rebuild, a new secret manager, a certificate cleanup initiative, a rollout of a bot platform. Those efforts can help for a while, but they tend to fade when the sponsoring leader moves on, or the next shiny priority arrives. What you actually need is a platform mentality. Someone should own machine identity as a product, with a roadmap, service-level expectations, and a clear mandate to make it easier and safer for teams to do the right thing. That platform describes reference patterns, publishes libraries and integrations, and measures success by reduced outages and reduced reliance on ad hoc exceptions. Bots and agents make the ownership question even more pointed. Robotic process automation, RPA tools, create digital workers that log in like people but act with machine speed across financial, operational, or customer systems. Artificial intelligence, AI assistants, are starting to call back-end services, initiate changes, and trigger workflows on behalf of employees. If each of these is treated as a special snowflake living under a one-off exception, you quickly accumulate a zoo of high-privilege machine identities that are almost impossible to govern. A mature approach insists that bots and agents use the same lifecycle as other machine identities. They obtain short-lived credentials from the platform, they operate under narrowly scoped permissions, their actions are logged in ways that humans can audit, and they are decommissioned or rotated like any other workload when they change roles or retire. Looking ahead, the pressure on this trust fabric is only going to increase. AI agents will get better at chaining calls across many services without direct human oversight. Software supply chain security is pushing organizations towards signing artifacts, attesting builds, and verifying provenance at each stage of delivery. The Internet of Things, IoT, and edge computing models are deploying fleets of devices and workloads in environments where physical access and maintenance windows are unpredictable. Every one of these trends adds more machine identities, more keys, and more reliance on automated trust decisions. The decisions you make now about authorities, credential lifetimes, and automation interfaces will determine whether that future is manageable or chaotic. You do not need to predict which specific tools or architectures will dominate. You do need to make a few durable structural choices. Consolidate and harden a small set of trust anchors, instead of letting new roots and authorities proliferate unchecked. Default to identities that are short-lived and bound to narrow purposes, so that theft and misuse are naturally constrained. Require that new platforms, automation tools, and AI systems integrate with the existing machine identity lifecycle instead of standing up their own isolated credential stores. Insist on observability for how non-human identities are issued, used, and revoked, so that you are never guessing in the dark during an incident. These discipline choices are the foundation on which future flexibility rests. When you internalize this view, the narrative around outages and incidents starts to change. You stop accepting someone forgot to renew a certificate as a complete explanation and start asking why renewal depended on a person's memory in the first place. You question integration designs that hinge on a single long-lived token and push for patterns that can be revoked and reissued with minimal friction. You treat machine identity metrics and trends as part of your operational health story, alongside uptime and security posture. Conversations with boards and regulators shift from an emphasis on human authentication to a broader view of how your systems trust each other and how that trust can be withdrawn when needed. In the end, this story is about reclaiming the map of who and what your systems trust. Machine identities will only grow in number and importance as automation, AI, and distributed architectures advance. You cannot stop that tide, and you would not want to, because it is where efficiency and new capabilities come from. What you can do is decide whether your certificates, tokens, keys, and bots evolve into a coherent, well-governed platform or remain a noisy, fragile swarm that occasionally bites you in public. A good starting point is to ask your teams whether they can produce a believable picture of your non-human identities today, and to ask who feels accountable for making that picture simpler and safer a year from now. The answers will tell you how close you are to calming the machine identity riot before it turns into your next headline for all the wrong reasons. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.